My dear students, today we are start the thermodynamics chapter in this crash course. My dear students, one or two questions are asked in crash course or in NEET exams in thermodynamics chapter. My dear students, we are discuss the important questions which are asked in previous 20 to 30 years in NEET exams, as well as we can discuss the concept, formulas, and how can solve these problems. What are the in these problems? What are the tricks are applied? So, my dear students, we can study the question number. First, we can start, and starting now, that is the question number 1. Here, my dear students, we can see here question number 1. Which of the following are not state functions? Q plus W, number 1. Number 2 is Q, number 3 W, number 4 H minus Ts. Now, my dear students, what are the concept and what are the concept of these questions? You know what are the state function. First of all, you know what are the state function. So, here we can write here concept state functions. State functions, what are the definition of the state functions? My dear students, state functions or state variables are those which are not depends upon the path. My dear students, these are only depends upon initial and final state. Here, my dear students, state functions are those which are not depends upon this path. It's only depends upon initial and final states. So, these are called, my dear students, state functions. Now, we can see that which are the questions, which are the answer of this question. Now, we can here see the second here Q. Q is a heat, and my dear students, here you can see the work. Q and heat, these are called path functions. So, what are the path functions, my dear students? Path functions. Path functions are those variables which are depends upon path. Means these are not depends upon initial and final state, these are depends upon path, how you can go. For example, my dear students, you can here see the number 1 is a Q heat. If you can walk the 1 kilometer, then you can consumption of heat in 1 kilometer Q1 and consumption of heat in 2 kilometer Q2. Q2 is greater than Q1, means it's depend upon kilometer, it depends upon path. So, it is called heat is a path function, not a state function. Now, we can see here W is the work, my dear students, and work, you know the work, when you done the work is done in 1 meter or 2 meter, then it is depends upon the path. So, my dear students, your car is working, and you drive your car in 1 kilometer, then work is done in 1 kilometer, and this piston is work in 1 kilometer. That's why this is the depends upon the path. So, work and heat is the example of path function. These are not example of state functions. So, my dear students, question number 1, which is asked in 2008 NEET exams, you can go the answer B. B is the correct answer, question number 1. Now, my dear students, we can see here question number 2. In a closed insulated container, a liquid is stirred with a paddle to increase the temperature. Which of the following is true? Here, when you paddle to increase the temperature, it means, my dear students, paddle is done the work, and when paddle is done the work, you can, what is the concept and what is the formula? Concept and formula of this question. My dear students, formula is, you can see here delta U or delta, or you can see the first law of thermodynamics, that is Q बराबर delta E plus W, because you can see here delta E बराबर Q plus W and here Q बराबर delta E plus W, because here system is closed. So in closed system, here system is insulated, closed and insulated. Closed and insulated system means, insulated means same as a thermos flask. Your thermos flask is the example of closed and insulated system. In this closed and insulated system, Q that equal to 0, because no heat is inside, no heat is coming and no heat is going from this system. So you can say that Q is equal to 0 for this insulated system, closed insulated system. And my dear students, pedal, here you can see the pedal to increase the temperature. It means pedal is work done. Pedal work is done on the system, because this is given by your question. So my dear students, that means W is not equal to 0, because work is done. When work is done on the system or by the system, it means W is not equal to 0, and hence internal energy of the system increases. Hence internal energy, because it is given by the increase the temperature, internal energy of the system increases. And my dear students, when internal energy of the system is increases, means delta E is not equal to 0. Why? Because delta is change. When internal energy is change, then change in delta E, it's a change in internal energy. It is also change, my dear students. So you can see here delta E, W, both are is not equal to 0 here in A option, and Q is equal to 0. So my dear students, you can, this is the formula, and we can see according to this question, a closed system, insulated container, a liquid is stirred with a paddle to increase the temperature. When temperature is increases, it means change in internal energy is done, and when paddle is work is done on the system, means W is not equal to 0, but it's a closed insulated, which is given in the in this question. So my dear students, Q is equal to 0. So you can see here your answer is A. Question number 2, answer is A, and this question is also asked in 2002. Now my dear students, here we can see the question number 3, which of the following is correct equations. Here my dear students, we can, what are the formula of this question? Generally we can see that delta E barabar Q plus W. Delta E is equal to Q plus W, and here you can see in NCERT book, here delta E is also represented by delta U, that equal to Q plus W. When my dear students, you can see here, this is that Q. What is the Q? Q is the heat given to the system. Heat given to the system. That's why Q is the plus Q. And this is the plus W, my dear students. It means work done on the system. On the system. When work done by the system, that then my dear students, it's a minus W. Minus W means work done by the system. So my dear students, here work done by the system minus W, plus W work done on the system, plus Q heat given to the system, and here you can see minus Q means heat, this heat given out from the system, and when heat given out from the system, it means minus Q. So, my dear students, formula is the first law of thermodynamics, and you can see what is the formula in this. Question number 3, you can see here delta U that equal to Q minus W. It may be a correct equations. Why? Here this is the plus Q means heat given to the system, and minus W means work done by the system. When heat given to the system and work done by the system, then you can see the correct option is B, question number 3. This question is also asked in 1996 exams, and these are the formula and theory and concept. Because my dear students, formula is this one, these are the theory and these are the theory and concept. Plus Q for given heat given to the system means in system heat is increases. So, here plus Q. When you have a system, closed system, and you can give the Q heat. So, heat of the system is increases internally. So, plus Q is, we can get the plus Q sign. And my dear students, when heat is given out to the system, then you can get here minus Q sign. When work is done on the system, then it is plus W, and work done by the system, it is called minus W. So, my dear students, you can see here question number 3 answer is B. Now, we can go to the question number 4. My dear students, question number 4 is asked in NEET 2020. The correct option for free expansion of an ideal gas under adiabatic conditions and formula and concept. In this formula, my dear students, we can here see the P external that equal to 0. Why? Because here in question free expansion of an ideal gas is done. For free expansion, when ideal gas free expansion of an ideal gas. When ideal gas done the free expansion, it means P external is equal to 0. We can see here, and what is the formula, my dear students? That is the formula is W that equal to minus P external into delta V. Delta V. Here, when free expansion of an ideal gas, then here delta B is equal to 0, and when delta V is equal to 0 and 4 adiabatic. What is the adiabatic process? My dear students, adiabatic process are those processes in which change in heat, Q heat is that equal to 0. Those processes are called adiabatic process. Now, my dear students, for adiabatic process Q is equal to 0, and when this Q is equal to 0, P external that equal to 0. So, my dear students, you can see the formula in first law of thermodynamics, delta U that equal to Q plus W. Here you can see the Q is equal to 0, W is equal to 0 because P external is equal to 0. So, this whole is 0. So, delta U is equal to 0. Delta U is the internal energy of an ideal gas. Delta U, this is a delta U internal energy of an ideal gas is a function of temperature. So, my dear students, here you can see the delta U is equal to 0. So, delta U is equal to 0, it means temperature is not increases because internal energy of an ideal gas is a function of temperature. So, when delta U is equal to 0 means change in temperature is also 0. So, my dear students, in adiabatic, correct option for free expansion of an ideal gas under adiabatic condition, here you can see the in adiabatic condition P external is equal to 0. So, W is equal to 0, and for the adiabatic no heat is given and no heat is out from the system. So, Q is equal to 0, and when we put the formula of first law of thermodynamics, and it is the delta U is equal to Q plus W, then Q 0, W 0, then delta U is equal to 0. And what is the delta U, my dear students? Delta U is the internal energy of an ideal gas, is a function of temperature. So, my dear students, it is a function of temperature. So, delta T is also equal to 0. So, my dear students, question number 4, you can go to the option A is the correct answer. Here Q is equal to 0, delta T is equal to 0, and W is equal to 0. Now, we can see the question number 5, my dear students. Under isothermal conditions, a gas at 300 Kelvin expands from 0.1 liter to 0.25 liter against a constant external pressure of 2 bar. The work done by the gas is given by, and what is the concept and formulas. We can see here, my dear students, we can see here concept and formulas, and this is the here work done by the gas, and here you can see this volume is changed, volume is taken, work done is taken, W volume both are, and isothermal means temperature is a constant. So, my dear students, you have a formula, that is W is equal to minus P external into delta V. You have formula this minus P external delta V. What is the delta V, my dear students? V2 minus V1 is called delta V. That you can put these values. P external, that is a P external is a given in that is 2 bar. So, you can put the 2 into V2. V2 0.12, 0.1 is the initial V1 and V2 is the 0.25. So, my dear students, you can put the 0.25 here, 0.25 minus 0.1. Then you can get the minus 2 into 0.15 bar. So, here W, that at W is equal to, you can get the 0.15 means minus 0.30, and this is the bar, my dear students. And here you can see your question is asked in joule or kilojoule. So, you are multiply by the bar is multiply by you can multiply by this joule, because here 1 liter bar is equal to 100 joule. So, you are multiply this 100, and when you multiply this 100, you can get the minus 30 joule, because here minus is, this point is replaced. You can easily calculate it, this one, this point is replaced by 20, here this 20 is cancelled out, and you can get the 30 joule. So, my dear students, your answer is question number 5th. So, your answer is B, because in B you can get the minus 30 joule, and here sign is the minus, because here minus P external into delta B, this is the formula which are used in conditions, and work done is done by the gas. Now, we can see this question. After this question is asked in NEET 2019, and your answer is minus 30 joule. Now, we can go to the question number 6, my dear students. Here, reversible expansion of an ideal gas under isothermal and adiabatic conditions are as shown in the figure. Here, AB is the isothermal expansion and AC is the adiabatic expansion. Which of the following option is not correct? Here he want the not correct answers, and in this condition, what are the conditions, my dear students? Here you can, for an ideal gas, for an ideal gas, internal energy is a function internal energy is a function of temperature, you know very well. For an ideal gas, internal energy is a function of temperature, final temperature. So that is final temperature is Tc. Final temperature is Tc for adiabatic process is less than its initial process or initial temperature. Adiabatic process is less than initial temperature. This is the final temperature. Here you can see final temperature Tc for adiabatic process less than its initial temperature, and initial temperature is a Ta. So my dear students, here you can see the in option it's Ta is equal to Tb, Tc and Ta, it's a less, and here which of the following option is not correct? You can see the D option, it is not correct. Correct option is this one, Tc is less than Ta. This is the correct option, correct answer. So here it is given us Tc is greater than Ta. Here my dear students, when you see the graph between the pressure and volume, this graph is a reversible expansion of an ideal gas. Isothermal means temperature is a constant here, and adiabatic process you see this heat is 0, and when heat is 0, T is delta T is also 0, and when delta T is also 0, it means temperature is now changed. So in adiabatic process temperature is not changed. So final temperature is Tc, and that for adiabatic process Tc is always less than the temperature of Ta. So Tc is final temperature always less than the initial temperature. Here you can see the answer, your D option is the correct answer. Now we can see here my dear students question number 7. A ideal gas expands isothermally from 10 to the minus 3 cubic meter to 10 to the minus 2 cubic meter at 300 Kelvin against a constant pressure of 10 to the power 5 Newton per meter square. The work done on the gas. What is the formula and concept? My dear students, here work done on the gas. He asks the work done W bravo minus P external into delta V. Now my dear students, you can see here that is the minus P external into V2 minus V1, and you can put the values minus P. Pressure is given the 10 to the power 5 Newton per meter square, and this volume 10 to the minus 3 to 10 to the power minus 2. So you can here see that 10 to the power minus 2 to this is the V2 10 to the power minus 3. So my dear students, that is W is equal to minus 10 to the power 5 into, when you calculate this, 9 into 10 to the power minus 3. So it is the minus 9 into 10 to the power 2, because here minus 3 and 5. So 5 minus 3 are cancelled with each other. So you can get the 2, and when you can get the 2, minus 2 into 10 to the power 2, it is a Newton per meter square, and this Newton per meter square is converted into the joule, and you can get the 900 joule, because 1 Newton meter per square is equal to 1 joule. So here you can directly write here minus 900 joule. So question number 7, you can go to the answer, minus 900 joule is the correct answer. So it's a very easy question, and this question is also asked in NEET 2019, because here only put the values and get the answer, and your formula of this question is W is equal to minus P external into delta V. Now, my dear students, we can go to the question number 8. Here question number 8, a gas is allowed to expand in a well insulated container against a constant external pressure of 2.5 atmosphere from an initial volume of 2.50 liter to a final volume of 4.0 liter. The change in internal energy delta U of the gas in joules will be. My dear students, you can use here formulas, two formulas are used, and concept and formula. Concept and formula of this question. First of all, you can see here, you can calculate that W, because here change in internal energy delta U is equal to Q plus W. So, you can first of all, you can use the first formula, that is W is equal to minus P external into V2 minus V1. Here, my dear students, pressure is given, that is minus 2.5 atmosphere. Here you can see the 2.5 atmosphere, and here V2 means this 4.50 is a V2 and initial volume is 2.5. Initial volume is V1, you can take, and final volume is V2. So, my dear students, you can take here 4.0 minus 2.0. So, minus 2.5 into 4.0 minus 2.0, it means you can get the minus 5 liter atmosphere. Why, my dear students? Because 4.5 and minus 2.5, you can get the 2, and 2.5 is multiplied by 2, then you can get the minus 5 liter atmosphere. Okay. It is the, my dear students, it is a W. Now, we can use the second formula, and what is the second formula of us? Delta U is equal to Q plus W. My dear students, what is the Q? Here you can see here question. A gas is allowed to expand in a well insulated container, and you know, in insulator container, heat is not coming out or given to the container. So, my dear students, Q is equal to 0 for insulator container. So, it is a 0 and plus, and you can get the minus 5 liter atmosphere. Here, my dear students, this liter atmosphere is converted into joule, because here in all options these are given in joule. So, liter atmosphere is multiplied by the here 101.325 joule, because 1 liter atmosphere, that equal to 101.325 joule. So, my dear students, you can see here 1 liter atmosphere, that equal to 101.325 joule. So, here you can see that it is multiplied, it is a liter atmosphere. So, it is multiplied by 101.325 joule. When, my dear students, you can multiply these values, you can get the minus 505, it's a 506.625 joule, and this is approximately, my dear students, W is equal to minus 506 joule. Here you can see the question number 8, answer is B, minus 505. So, it is approximately same, minus 505. So, you can go the answer B, question number 8, your answer is B. This question is also asked in NEET 2017. You can apply two formulas and conversion of this unit, liter atmosphere is converted to joule. Then you can get the answer. Now, my dear friends, we can go to the question number 9. Equal volumes of two monatomic gases A and B at same temperature and pressure are mixed, the ratio of specific heats Cp upon Cv of the mixture. Here my dear students, concept and formula. What is the concept of this question and what is the formula? For here monoatomic gases are given, my dear students, and he wants the Cp upon Cv ratio for monoatomic gases. My dear students, here monoatomic gases mixture of same volume. Here volume is same or equal. It means it's a 5 upon 2 into R. Same volume, it's a 5 upon 2 into R. Monoatomic gases and same volume, that equal to 5 upon 2 into R. This is our one point. Now, my dear students, we can see the what is the Cv. Cv is equal to 3 by 2 into R. Now, we can here see the ratio Cp upon Cv. Then, my dear student, it is say 5 upon 2 into R upon 3 by 2 into R. We can calculate it. Here you can see this 2 go and multiply with this 5 and this 2 is multiplied with this 3. Then, my dear students, you can get Cp upon Cv, that equal to 5 into 2 into R upon 3 into 2 into R. So, my dear students, here this R are cancelled with each other, 2 and 2 are cancelled with each other, and you can get the 5 upon 3. This is a 5 upon 3, my dear students. This is the ratio Cp upon Cv, that equal to 5 upon 3, and when you can divide this 3 this 5 by 3, then you can get 1.67. So, my dear students, this is your answer D. You can go the answer D. Question number 9, answer is your D. And this question is also asked in 2012. We can see the here concept for monoatomic gases of same volume, that is the same volume by 5 by 2 into R, or it is called constant pressure. So, it is also called the Cp. This is the question, my dear students, 1.67 answer of this question. Cp upon Cv is equal to 1.67. Now, we can go to the question number 10. Which of the following is correct option for free expansion of an ideal gas under adiabatic conditions? Here, my dear students, adiabatic condition, what is the concept? This concept is already we can discuss for adiabatic conditions. No heat is come out or no heat is given. So, Q is equal to 0, and when this heat is function of temperature, that is why delta T is equal to 0, and my dear students, when both are 0, and you can see that here free expansion is done, and free expansion of an ideal gas, this is the condition, then you always that W is equal to 0. So, my dear students, here you can see the question number 10th, you can go the answer C, because here Q is equal to 0, delta T is equal to 0 and W is equal to 0. This question is also asked in 2011 NEET exams. So, you can this conditions of adiabatic, my dear students, you must be learned these are conditions of for adiabatic. Q is equal to 0, delta T is equal to 0, W is equal to 0, no work is done when free expansion of an ideal gas. Now we can go to the question number 11. 3 moles of an ideal gas expands spontaneously. It's into vacuum. The work done will be. What is the formula and concept? Concept and formula. Here, my dear students, ideal gas work done for the ideal gas means W is equal to minus P external into delta V. You have this formula, and here you can see the P external that equal to 0, because this work is ideal gas expands spontaneously into vacuum. When vacuum, in vacuum P external is equal to 0 in vacuum. Ideal gas expands spontaneously, expands spontaneously. So, my dear friends, P external is equal to 0, and that P external is equal to 0, it means this is multiplied by delta V, it means W is equal to 0 for question number 11, and your answer is D. You can go to the D answer by this, use this formula. W is equal to minus P external into delta P, and this question is also in mains 2010. Now, my dear students, we can go to the question number 12. Assume each reaction is carried out in an open container, for which reaction will delta H is equal to delta E. Here, my dear students, this question is asked in 2006, and what is the concept of this question? Concept and formulas. Here we can see delta H is equal to delta E plus delta NGRT. This is a formula we can use. Delta H is equal to delta E plus delta NGRT. And what is the delta NG, my dear friends? Delta NG is the NP minus NR. And what is the delta NG? Here number of gases, number of change in gaseous moles. Here you can see that equal to NP. What is NP, my dear friends? NP is the number of gaseous moles of products. What is the NR? NR is the number of gaseous moles of reactants. So, my dear friends, delta NG is this one. Here you can see when delta H is equal to delta E, he wants this condition. Delta H is equal to delta E. It means delta NG must be 0. When delta NG here 0, then 0 is multiplied by these quantities, you can get the 0. So, you can get delta H is equal to delta E. Delta NG is equal to 0 in what conditions? In that condition when product and reactants are equal, NP and NR equal, and when both are equals, then 2 minus 2 that equal to 0, you can get that. Here you can see the answer 1. Here you can get 2 minus 3, it is not 0. So delta Ng is not 0, this is not answer. You can go to the B option, H2 plus Br2, 1 mole of hydrogen, 1 mole of Br2, you can get 2 moles, and here you can also get 2 moles. 2 minus 2, that equal to 0. So my dear students, this is your answer, question number 12, B is the answer. Why? Because 2 minus 2 and 2 minus 2 is equal to 0. So delta Ng is equal to 2 minus 2, that equal to 0, and when you can put this 0 in this formula, this whole quantity is 0 and you can get the delta H is equal to delta E. So my dear students, question number 12 answer is B, and this question is asked in 2006 exams. Now we can go to the question number 13. The work done during the expansion of a gas from a volume of 4 to 6 against a constant external pressure of 3 atmosphere. My dear students, when in this type of questions are asked in NEET exams, work done during expansion means you can use formula of work done, concept and formula. Which formula? You have only one formula, that is W is equal to minus P external into delta V. You always use this formula when you can get this volume is changed here, you can get the pressure, external pressure, that is equal to minus 3 into delta V is V2 minus V1. So you can get the minus 3 into, that is V2 is equal to 6 minus 4. So my dear students, W is equal to minus 3 into 6 minus 4, that is 2. So you can get 3 to the 6 minus 6, but it's a atmosphere. So my dear students, you can change this atmosphere into liter, multiply by the, here 1 liter atmosphere 101.32. So you can multiply by this 101.32 and it is converted to joule. So minus 6 into 101.32, then my dear students, you can multiply this and you can get the minus 607.925, and it is approximately, my dear students, minus 608 joule. So you can go the answer B, question number 13, you can get the answer B. This question is also asked in 2004 exams. Now my dear students, we can see the question number 14. For the reaction C3H8 gas plus 5O2 gas, 2 gives rise CO2 gas plus 4H2 liquid at constant temperature, delta H minus delta E is. Here my dear students, what is the concept and formulas? Here you can see formula is delta H, that equal to delta E plus delta nRT. Here my dear students, delta H minus delta E, that equal to delta nRT. So in this question, he want the, what is the delta H minus delta E, means you can find out that this delta nRT, and you know very well delta Ng is equal to Np minus Nr. So my dear students, number of moles of products you can see here, gaseous, here 3 plus 4, but in 4 you can get the liquid. So this liquid is not taken in this formula, only gaseous moles of products we can take, 3 minus. Now we can here see 5 mole of gas, 5 and 1 here 6, 3 minus 6. My dear students, that equal to, you can get the minus 3 delta Ng. Now we can put the minus 3 and RT. You can see the options here, in all options this RT is not multiply, R values of this R and T is not multiply. So this question is very easy for you, my dear students, and you can get the delta H minus delta E, that equal to minus 3 RT. So this is the answer. minus 3 RT. My dear students, you can go to the question number 14. B is the answer, minus 3 RT. This question is also asked in NEET 2003 exams. Now, we can go to the question number 15 here. The molar heat capacity of water at constant pressure C is 75 joule Kelvin per mole. When 1 kilojoule of heat is supplied to 100 gram of water, which is free to expand the increase in temperature of water. Here, my dear students, you can see here concept and formula. Concept and formula to solve this question. Here, my dear students, you can see here molar heat capacity Q is equal to, you can put this formula, Q is equal to m C into delta T. This is your first formula, and you can put this formula and get the answer. Now, we can here see what is the molar heat capacity here given you. Molar heat capacity. Molar heat capacity that equal to 75 joule per Kelvin. It is given by you, and here when 1 kilojoule of heat is supplied to 100 gram of water, and it is a molar heat capacity, means what is the molar heat capacity? We can theoretically we can see here 18 grams. 18 gram is the molecular weight of water. 18 gram of water means molecular weight of water, that equal to 1 mole, and when this 1 mole is taken the 75 joule per Kelvin. What is the molar heat capacity when 1 mole of water get the heat to increase the temperature of 1 Kelvin or 1 degree Celsius? It is called molar heat capacity. Here we can see the molar heat capacity. When, my dear students, 1 mole of the water, 1 mole of the water accept amount of heat to increase temperature of 1 Kelvin or 1 degree Celsius. It is called molar heat capacity. Now, 1 mole of water get the molecular weight, that is 18 gram. So, 18 gram of water that equal to 1 mole, and 1 mole here molar heat capacity of water. It is given by in the numerical. So, it is a 75 joule per Kelvin or 75 joule per Kelvin. Now, we can see here 1 gram of water, 1 gram of water accept that is 75 upon 18 grams, and now here 100 gram of water, that is 75 upon 18 into 100 joule. (75 upon 18) 100 into 100 joule per Kelvin. So, my dear students, here you can see the molar heat capacity is converted or it is required for 100 gram of water, which is given in your question he wants. So, my dear students, you can see here Q here 1 kilojoule of heat is supplied, here 1 kilojoule, and here this is a joule. So, you can convert into kilojoule into joule. So, heat supply is a Q is the heat supply, Q is the heat supply. So, it is converted to 1 kilojoule to 1000 joule. Now, my dear students, here mass of the gas, mass of the water, that is 100 multiplied by the, here you can see the C, that is molar heat capacity is the C here, and we can calculate here, that is the molar heat capacity 75 into 100 upon 18, and my dear students, we can calculate the delta T, because here in this numerical delta T, he is asked the delta T, which is free to expand the increase in temperature of water. Increase in temperature of water means he wants this delta T. He wants the delta T. Delta T is the increase in temperature. So, we can get the all values, and when we can get the all values, you can solve very easily. 1000 into 100 into 75 into 100 into delta T upon 18. So, you can solve this delta T 1000 into 18 upon, you can get the 100 into 75 into 100. So, my dear friends, we can solve it. 1 0 1 2 2 3 3. Here you can get the 100 into 100, okay, 75 upon 100. You can get this mass here, na, 100 gram, because mass is, this mass is already multiplied. So, my dear students, you cannot get this mass, na, because mass is already multiplied. So, this 100 is, you can remove here, this 100. Only you can get the 75 upon 100. So, this 100 you can remove. So, you have only this 100 upon 75 upon 100, because 75 upon 100 into 100, mass is already, this mass is already, we can take here. So, 100 into 75 into delta T, and you can see here, this is the 100. So, when you can take this 100 and 1000 here, 1000 into 100. So, you can here remove this 100, and here 1000 you can get 1000, 1000. Now, you can cancelled of 0, that 1 and 2, then you can get the 10 into 18 upon 75. This is the delta T, my dear students, 180 upon 75, and when you can get the 180 upon 75, then you can get the 2.4 Kelvin. This is your answer, 2.4 Kelvin. So, this is the calculations, and what is the molar heat capacity, I give you the definition also. So, this is the concept I give you, this is the formula I give you, and what is the, where this molar heat capacity C is converted, because in 100 gram of water is already taken, then M is already taken, or you can see this is the MC here, these are values of MC, and this you can put these values of MC and you can get the answer. Now, my dear students, we can go to the question number 15, answer is B. B is the answer of these questions.